Hi folks, Matt McSpirit here, Technical Evangelist and member of the Ops team here at Microsoft. As we continue our look at 10 reasons why you'll love Windows Server 2016, we're back on the Redmond campus here at Microsoft to meet with Ravi Rao from the networking team, who's going to give you all you need to know about networking in Windows Server 2016. Let's go. So welcome Ravi, thanks for joining me. Tell us what you do at Microsoft.
So I'm Ravi Rao. I'm the networking troublemaker at Microsoft.
Very nice.
More seriously, I help lead the software-defined networking team that plugs into Windows Server and Microsoft Azure stack.
Nice. So bring us up to speed with some of the pain points we're trying to address, specifically in Windows Server 2016 around networking.
So there's 3 pain points I commonly hear from customers. The first is around a lack of agility. They want to deploy apps fast, they aren't able to.
Okay.
The second is around security. Security is just a very, very big deal nowadays, as you may have heard.
For all organizations.
For all organizations. And the third is around flexibility, just having complete control over your workload. So these are the 3 common pain points I hear from customers.
So when it comes to agility, you mentioned applications, and that's incredibly important for organizations, large and small. But help us understand agility in the context of networking. What does it mean, and what are we solving for?
Yeah, so the way to think about it is you have a business group. What does a business group want? It wants to take services that it has and make them available to customers as soon as is possible. Right? So I have a service, my developers just built it, I want to get it into production as quickly as possible. Well, the problem is these workloads and these services aren't that simple. There may be a front end, a middle tier, a back end. There may be a lot of policies surrounding all these workloads, policies around load balancing, policies around firewalls, policies around quality of service. There may be a lot of policies that have to get applied. And by the time you have the IT department take all these policies and model them on the actual physical network itself, onto the different physical appliances.
In production.
Yeah. Well, that takes a lot of time because IT and your network admins have to do the IP mind maths to figure out what are the right IP ranges. They'll have to figure out what is the VLAN that I need to get extended and think through all those kinds of problems. And by the time you have gotten to the physical network and done all the deployment, weeks, if not months, have passed.
Right.
And you have the business group wondering, I really want to get my workload deployed. I really want to get my workload, my service, become available to my customers.
Yeah.
I really want to be competitive. And so the problem basically the business group has is a lack of agility in being able to get their workloads, their services deployed as fast as is possible.
In comparison with, say, the public cloud, where it's click, 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 and everything's very agile.
Exactly, as opposed to Azure, where I do a click, 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 and my workload is deployed. In fact, in Azure, we have more than 90,000 customers. We onboard every single month. And you cannot have 90,000 customers onboarded every month if you're going to be, for every single workload, for every single change, if you have to go and make changes in the physical network. You simply cannot do that.
Plugging cables in manually.
It's just not doable. It does not make any sense. You simply cannot do that. And so what we're saying is that the model for agility that we have built in Azure is the model for agility that we're bringing with the software-defined networking stack into Windows and Microsoft Azure stack.
Cool. So tell us about security. Very important. So how does that play in the networking world?
Yeah, so security is one of those things where we find customers coming and saying, I simply cannot afford to have another breach. I simply cannot because my reputation is at stake, I'm losing customers and whatnot. And so the way they go about solving for this problem is by putting heavy perimeter defense. So I have big firewalls that I'm putting at my perimeter, and my workload is going to sit behind it. My front end, my middle tier, my back end, they're all sitting behind this big firewall, and that firewall is going to protect me.
Yeah.
Well, in many cases it does, right? They do their job. They do their job well. And in many cases the workload is protected. But very often you have attacks penetrate through. right? So an attack comes from the internet, infects one machine, or as we have seen more recently, breaches can happen from within. It infects one of the VMs associated with the front end, and now it starts spreading laterally within the data center and then across your workload, across all the tiers of your workload. Suddenly, you have to go back to the business group and say, I'm sorry, but we have a security breach. Your service has to be taken down. My customers are angry, my shareholders are angry, and I have just lost all credibility in this space.
So it has huge ramifications for the infrastructure.
Huge ramifications for the infrastructure and for the workload owners, for the service providers. And so what we're doing again is to say that security is something that an application has a good sense of how it wants to be modeled.
Right.
So an application may say that, you know what, the internet should only be able to communicate with my front end. It should not be able to communicate with my middle tier. It should not be able to communicate with my back end. I only want it communicating with my front end, nothing else. And even within the front end, I don't want my machines to be able to communicate with each other so that if one of them gets infected, the other one's not going to suddenly be susceptible to attack.
Right.
And so the idea is you can model these policies easily in a template. The same template that was used to model the application can now also be used for modeling the security profile of the application, the security policies of the application. And now effectively what can happen is you can segment your network, dynamically segment your network based on what security policies the app wants to see. And if those security policies change, you don't have to go into the physical firewall and make all these individual changes, which takes time. You can just do that in software, in that template, in that one template, and those policies automatically get disseminated to all the instances that need it.
And as those workloads float around the infrastructure, because agility, live migration, and so on, the policies
they just move with it.
Yeah.
The policies just move. And you can bolster that. So you can say that, you know what, I have policies that are preventing, for instance, VMs from communicating with each other, which is a good thing. But when I'm going and talking to my backend, I want it to go through a firewall appliance I trust.
Right.
Well, no problem. You can route traffic to go through a firewall appliance dynamically so that you get the level of trust that you care about while retaining the ability to dynamically make security changes when needed.
So that dynamic nature it promotes a lot of flexibility. So tell us a bit more about the flexibility overall in the networking stack.
Yeah, so agility was the first one. You know, deploy your apps fast. We talked about dynamic security, how you can dynamically deploy security policies associated with workloads. And the third thing is around flexibility, like you said, which is fundamentally saying that I have workloads today that remain somewhat sticky. They're sticky to my server, they're sticky to my rack, they're sticky to my on-premises data center. And I want to unstick them because I want to have control over where my workload is running, whether it's on one server or another, whether it's in one rack or another, or whether it's in my data center or in a public cloud. And so that level of flexibility is something that workloads and IT administrators lack today because they are constrained to, you know, hardware dependencies that they may have taken or to certain VLANs that are configured on the switches, policies, so on and so forth. Like you were saying earlier, the policies don't move with the application, which is exactly the thing you need if you want flexibility. So what we've done is virtual networking. With virtual networking, you can bring your own IP addresses and they will move with you. You do not have to change IP addresses if you go from server to server, from rack to rack. You can move these across physical subnets underneath the covers without having to renumber the IPs. You can bring overlapped IP addresses. So you might have one department bringing in a 10.1 address, you have another department bringing in a 10.1 address, no problem. These float as individual bubbles, individual sandboxes on top of a shared infrastructure.
Nice.
In addition, it's hybrid. So you have the power to go into Azure or come back from Azure or into your favorite Azure Stack or Windows Server Powered Cloud and bring it back. You have the ability to do that. And Microsoft is somewhat unique here because we we have the ability to let you take your app or tier of your app, and you can choose to run it on premises. Tomorrow you may say, you know what, the economics of running it on premises is not worth it. I want to actually move it into my public cloud environment. You can move it into Azure, and tomorrow you may have a policy change that says, no, we don't want to be running anything in Azure. We want to be bringing it back for any number of reasons. No problem. You can just bring that back, and your app just continues to run exactly as is. You have complete control with hybrid flexibility over your workloads.
Cool. So I think it would be beneficial if we look at this in each of those in a little bit more depth on the whiteboard.
I'd love to do that.
Yeah, okay, cool. Let's go and take a look.
All right, great. So let's say you're a business group. Okay, so business group says that I have a very simple app. I have an app that has a front end with a couple of VMs in it. Okay, so this is your front end. I have a middle tier.
So this represents just a regular line of business application, could be internal, could be produced by a software vendor.
Exactly.
Right.
It's a regular line of business application that's, pick your favorite one. And this is the back end. Yeah, again, with a couple of VMs.
So multi-tier, multi-virtual machine
exactly.
application.
Your normal app from today's standards.
Right.
And each of these will generally be running in a subnet. So let's just pick some subnets for them. Something like that.
Okay.
And guess what? Yes, the front end has to speak to the middle tier has to speak to the back end, and the front end is accessible over the internet.
Nice. Okay.
That's my app.
So far, so good, yeah.
So far. And the business group now goes and tells IT, can you deploy this for me by tomorrow?
Nice. By yesterday.
By yesterday, exactly. And IT laughs.
Right.
And the reason they laugh is because as much as the workload looks simple, it's actually hiding a lot of complexity. There's a lot of policies that have to get deployed. You may have firewall policies. You may have quality of service policies.
When you say may, you should have.
You should have.
Yeah.
Yes, that's right. You should have firewall policies. You should have QoS policies.
Right.
You will have some switching policies, some routing policies, some gateway policies, some load balancing policies, so on and so forth. There's all kinds of policies that are associated with this workload.
Right.
And the problem is these are all deployed onto physical boxes.
In typical enterprises today.
In typical enterprises today.
Right.
Right? And so by the time you've taken the policy that the app has and modeled it onto these physical appliances sitting on the network, you have spent a lot of time, because it actually does take time to figure out how best to model policies onto the physical network.
Right.
Well, in Azure, such delays are not acceptable. Like I was telling you earlier, we onboard 90,000 customers a month into Azure. So if we want to have that kind of agility, we simply cannot, for every single workload we're trying to deploy, we simply cannot go in and make such changes on the network.
Right.
And so the way we do it is, first we virtualize all of these capabilities.
Okay.
Okay. So these are not physical policies anymore, and I'm kind of showing it as a dotted representation, if that's supposed to mean anything.
Represent a virtual machine.
Yeah,
I get
to
you,
represent either a virtual machine or policies that are not on a physical appliance. They're running on the host, for instance.
Right. So are these examples of what I've heard of network function virtualization?
Exactly. So if you think of network function virtualization, it's saying I'm taking a function that's typically running physical and I'm virtualizing it.
Right.
We go one step ahead to say that not all policies have to be running in a virtual machine. So you may have a load balancer, for instance, that yes, is running in a virtual machine, but if I have firewall policies or quality of service policies I want to apply, I don't need them to run in a separate virtual machine. I can instead take those policies and deploy them onto the hosts that the tenant workload is running on.
Right.
So effectively push the policy as far southbound as possible so that enforcement is faster.
Right.
If I have a firewall policy to enforce, I don't need to go to an appliance, have it be enforced before two VMs on the same host can talk to each other.
Use the host network switching infrastructure.
Use the host network switching infrastructure to do that. Exactly.
Excellent, makes
so
sense.
now what we do is we take all these policies and model them into a template. So effectively, you can now have a template that's modeling what the application topology and policies are. You can have your firewall policies, your load balancing, your QoS, L2, L3, so on and so forth.
Right.
Right? So now I have a standard way in which I'm representing my application.
Nice.
This I now feed into a scalable network controller.
And this is new in 2016.
This is new in 2016, right? This is how we do it in Azure. Build it into a scalable network controller that can be as highly available as you want it to be, right? So this is in a ring. And now the policies that come down here get deployed onto all of these functions.
Nice. So the network controller becomes an incredibly important role within the infrastructure.
Exactly. The network controller is your highly available brain of the network that takes policies, is aware of the hosts that tenant VMs are running on, provisions the policies down into the data planes of those hosts, provisions your load balancers and gateways, and does it in a matter of seconds. So your app, this app that you have here that you wanted to deploy in a matter of days can actually get deployed now in a matter of seconds instead of getting deployed in a matter of weeks or months.
And it's not just about the deployment, also network controller plays a big part in monitoring and troubleshooting going forward as well.
Exactly. The network controller has the state of the network,
right,
which means that you can troubleshoot and monitor a whole lot more easily.
Nice. Okay, so that brings us a bit more depth on agility.
Agility. So let's write that down. So we'll say unparalleled agility.
We won't test you on your spelling, don't we?
I know, thank you. You can test Word on spelling. All right.
So that's agility. So what about security? I think we've touched on a little bit of it already with the firewall, but help us understand in this architectural model, where does security fit?
Yeah. So for security, the way security is typically done, right, is customers will take and put a big firewall up front here, right? They'll say, you know what, I'm going to block everything that needs to be blocked and allow only those things that need to be allowed, right? And they do their job well. We don't, for the most part, they do their job well. But frequently, attacks do get through the firewall.
Right.
Right? Attack vectors do get through. And they can take out an instance running on your front end. But now, typically, security within a front end is not as tight because it's hard to do it on a physical network. And so they move laterally and can take out the rest of your workload front end as well. They can then move in this direction and take out your middle tier, they can take out your back end, and suddenly you have a security crisis on your hands.
Or even spread further into the internal network.
Spread further into the internal network.
Right.
You have a big security crisis at hand.
Yeah.
And so this is a problem we have in Azure as well. And so the model we use in Azure is to say that, you know, instead of, we need these firewalls. So maybe we still use these firewalls, but not for granular workload policies. Maybe for the overall physical infrastructure, we have some policies modeled in the firewall, but for granular workload level policies, we model them in this template itself.
Right.
So effectively, you can say that I have policies that say I am going to allow traffic to go through on port 80.
Right.
Okay, that's all I'm going to allow. I'm going to allow traffic to come in on port 80, and then I am not going to allow traffic between these VMs.
Right.
I'm going to disallow it because there is no need for those VMs to communicate with each other. Right? So these VMs cannot communicate with each other, which means that even if this VM were to go out and get infected, it would not have the ability to go out and
spread to
impact other instances running on the network.
Okay.
That's a big deal. But what's even better is tomorrow you may say that, you know, I have to allow port 80, but I also have to allow port 443 in. Easy. All you do is you change the template and basically say this is the additional port range that has to get allowed, and you just apply it and it'll automatically get applied across all the instances that need that policy.
Right.
So it's very dynamic. You have a dynamic security model because you have the ability both to model your your segments. You're effectively segmenting your networks. You have the ability to create these virtualized segments in the network. You can model policies between these. So you can say this is going to be allowed, this is going to be allowed, but this is not allowed.
Right.
This is not allowed. And you can model this very easily. You can change it very easily. And so effectively, this model effectively lets you create security policies that can be enforced and changed on demand.
Right.
But it gets even better. The way it gets better is that you may say, for instance, like I was telling you a little earlier, you may say that I want traffic between my front end and my middle tier not to go directly.
Right.
I actually want it to go through an appliance that I have, a virtual appliance that I have, a firewall appliance, for instance. I want it to go through this. You can do that.
Right.
Easy.
For a specific selection of workloads or VMs.
For a specific selection of VMs, for instance, or some specific traffic. You may want it going through this virtual appliance. Or you may say that I want to actually copy traffic down to a device. I want to mirror traffic down for analytics or anything you want to be doing. You look at the traffic and you say, oh, you know what? I think that traffic shows a pattern that's beaconing to the internet, let's say. And you know there's something suspicious in the traffic then. So you can mirror the traffic without impacting the data flow. All of this is dynamic. You can do this on the fly without having to, deal with the physical infrastructure.
Right.
All of this can be done dynamically.
And you can chain some of these together, so it
You
could be
can
firewall, then analytics, then on from there. It
If
doesn't
you
have to
needed
be
to.
one or... Yeah.
Yes, absolutely. If you
Nice.
needed to, you could do that.
Cool. Okay, and again, that's new in 2016.
That's new in 2016 as well.
Great.
So this is what I call the dynamic security model.
Nice. And good spelling as well.
Yeah, thank you. I'm learning.
So security and agility, we've covered those.
Yeah.
So the final area we touched on it is around flexibility.
Flexibility.
So where does that all fit?
So flexibility says that I have, for instance, let's say this tier, right? I have this tier, and I want to just take this tier and move it to Azure. Azure is our huge cloud.
Hyperscale.
Hyperscale.
Nice.
It won't fit in this building. It's too big. So that's why it's a very wide.
It's a wide cloud.
Wide
Very
cloud.
broad.
Very broad.
Right.
So this is my Azure cloud, and I just want to take this tier and I want to move it to Azure.
Right.
You can do that. You can say that, you know what, not just that tier, I want to take my entire app and I want to move that to Azure. You can do that too. You can tomorrow say that, no, I actually want to bring this app back. I want to bring this tier back. You can easily do that as well. So this is what I call hybrid flexibility, because Microsoft is unique in having both a public cloud offering and an on-premises offering, which means that you have the flexibility to determine where you want to do your cloud. You want to do it locally, you want to do it in Azure, you want to do pieces here, you want to do pieces in Azure. It's completely on your terms. You decide as a customer how you want to deploy your workload, and we provide the flexibility for you to do so.
Right, cool.
So the third thing, and let's see if I spell this right. My daughter just went for a spelling bee, and so I have been learning my spellings as well as a result.
Excellent, yeah.
It's hybrid flexibility.
Correct. So there's the three areas. We've got agility, which is unparalleled. We've got security. Now, flexibility, it wouldn't have to just be Azure. It could be as simple as within your own data center, moving between racks, moving between different geographies if you've got multiple data centers. It's just ultimate flexibility to help you shift things where it needs to be shifted to.
You stated it really well, Matt. I mean, it really is about saying that you have control over your workload.
Right.
You can move it from server to server, from one rack to another rack, or across clouds if you needed to.
Nice.
That's exactly right.
So I had one final question. Where does the new software load balancer fit into all of this? I've heard a lot about it. Where does it, obviously we talked about load balancing policies here. Where would it fit in our architectural view?
Software load balancer is everywhere. So you can have a software load balancer, for instance, over here, that is load balancing across these front ends.
Right.
You can have a load balancer that's sitting between these for east-west load balancing that load balances between these as well. And it's a really smart load balancer, because the beauty of our load balancer is that typically in a load balancer, you'll have traffic come into the load balancer, go to a particular destination from there, And then from the destination, the traffic goes back to the load balancer and then goes back to the client that initiated the request.
Right.
Well, by virtue of the fact that we're doing this all in software, we can say that we control both this load balancer and this virtual machine host that it is running on. And so we can send traffic back directly to the internet instead of having to go through the load balancer, which significantly reduces load on that load balancer and scales it up more.
Nice.
I mean, it's easy for me to issue a request that says, get me an image. Well, that image might be a huge image. If that image had to pass through this load balancer and go on up, it is seeing a lot more traffic than in the more distributed model we have, where you can have it directly respond over the internet, bypassing the load balancer basically and respond to the client that requested it.
Right.
So it's for both north-south load balancing and east-west load balancing.
As well. Now, so where has this load balancer come from? Is it an evolution of previous load balancing technology in Windows Server, or is this something new?
This is something new.
Right.
So we worked with our friends in Azure, basically, where they have a load balancer deployed at scale and brought very similar designs down into Windows Server 2016 as well. So this is a brand new capability whose design is tried and tested in Azure, and we are bringing that same design and making it available to all Windows Server customers.
Awesome. So everyone's got the chance of using it and
Yes.
benefiting. Cool. Well, thank you for the explanation. Let's go back and wrap up.
All right.
Great. So now we know a little bit more through architecturally and through the whiteboard what's going on around networking. Help us understand, for somebody who's perhaps new to software-defined networking in Windows Server, how is it best for them to get started?
The best way to get started really is to get your hands dirty.
Mm-hmm.
There really is no substitute to that. And to do that, you can download the evaluation guides that we already have available for you. All of our documentation, extensive documentation on how to plan an SDN deployment, what it takes to deploy, what it takes to troubleshoot. All these documentation is available on TechNet for your review as well. So my main ask is, download the evaluation guides, get a couple of servers, and start getting your hands dirty. And you'll find yourself amazed at how easy this actually is.
Great. Well, thanks, Ravi, for helping us understand a little bit more about the networking in Windows Server 2016. And hopefully you found it useful as well. And please stick with us as we continue the series looking at 10 reasons why you'll love Windows Server 2016. Thanks.